we want to look at the Newton-Raphson method of solving equations. Now, suppose you have an equation and you have your x-axis and your y-axis, and you plot a graph of your equation. The equation is of the form f of x is equal to 0. It could be quadratic, is equal to 0. It could be a cubic equation, is equal to 0, or some other equation, right? While you have other methods of solving your quadratic or your cubic or other equation, there are some equations that you cannot use algebra to solve. You could plot the graph, then look closely and see where on the graph x is equal to 0. What value of x is equal to 0? Right? But suppose you have a situation. You have a situation where you want to find x. This is x. Let's say we locate this other x here. Call it x1. Alright? And then we draw a tangent to x1, which represents the tangent to the curve at x1. Now this is a tangent. Use a different color for the tangent line. This is a tangent line. What we have is f of x1 being right here. And let's say at this point we have the tangent line crossing at x2. Then the gradient of the tangent is equal to the rise f of x1 minus 0 divided by the run, which is x1 minus x2. Alright? Now, the gradient is given by the gradient function, which is the derivative of f of x at x1. So here we say f prime x is equal to that function. F prime x1 is equal to f of x1 minus 0, because we're going down to the x-axis, which is y equals 0, minus x1 minus x2. What is x2? Where is it? Let's transpose this equation to get x2. So we multiply both sides by x1 minus x2, so we have f prime of x1 is equal, no, not equal to, times x1 minus x2 is equal to f of x1. Alright? So that's what we have. Now if we multiply out the brackets, f prime x1 times x1 minus f prime x1 times x2 is equal to f of x1. Now, remember, we want to find out where x2 is. Good. So let us add f prime x1 to both sides of the equation. We have negative f prime x1 times x2. Let's write x2 like that. is equal to f of x1 minus f prime of x1 times x1. Now, that's what we have there. So, x2, which we're transposing for, is equal to, let's divide both sides by f prime x1. We have f of x1 divided by negative f prime of x1 minus f prime of x1 times x1 divided by negative f prime of x1. So x2 is equal to, okay, so what we do now, we have f prime of x1 divided by f prime of x1, so this cancels. So we have f of x1 over negative f prime of x1 plus, because we have the minus negative, so it's plus x1. So we can rewrite this as x2 is equal to x1 minus f of x1 divided by f prime of x1. So that is the Newton-Raphson formula for finding a root, or in other words, the point where f of x is equal to 0. Now, once we do this, we can repeat the process. So from x2, and we point upwards, then we have another tangent line, right? Each time we draw a tangent line, we get closer to the true value. In this case, let's say this is x3. So we do the same thing to x2 and get x3, and we can repeat the process. So each time we repeat the process, we get closer and closer to the true value. Right? So that is the formula for the Newton-Raphson method of solving an equation. So we're going to make note of this formula, and we're going to use it in examples after this video. So I'll see you in the next video.